So in adding, subtracting, and multiplying polynomials, I'll be showing you how to use Pascal's triangle to expand a binomial to a power. For example, I have x plus 3 to the 4th power. Now over here, I have my Pascal's triangle all written out. Now, if you look at the chart, to the power of 4 would be 1, 4, 6, 4, 1 with these numbers, these terms. So when we write out x plus 3 to the power of 4, we can use these numbers that are in silver and put these over here. And then when we multiply these out, we get these numbers. So when you go to solve this and simplify it, then it becomes this equation here. Because, for example, 1x, which is just x to the 4th power, is x to the 4th power. 4 times 3 is 12. X to the 3rd power is 12x to the 3rd power, and so on and so forth. And that is how we use Pascal's triangle to expand a binomial to a power. Now, an example of multiplying two polynomials. There's multiple ways to go about doing this. In my example, I have x plus 2 multiplied by x plus 5. So we can first start off with this box method here, where we take x plus 2 by x plus 5. So we have x times x, which is x squared, and then we have our 2x's there. And then we know 5 times 2 is 10, so that's why we have 10 ones down here. And then we have 5 times x and 2 times x, which leads us to these. Or a more simpler way could be modeled by this box method, which is multiplying x plus 5 and x plus 2. Now we know 2 times x is 2x, and 2 times 5 is 10. We also know that x times x is x squared, and 5 times x is 5x. Now we can use this information, and I wrote it over here. X squared plus 5x plus 2x plus 10. And that can be simplified down to x squared plus 7x plus 10 when you combine like terms. Or another way to use this is the FOIL method, which I will use in the next example. And that is how you use an example of multiplying two polynomials. Now, an example of expanding a binomial cubed using Pascal's triangle. So over here again, I have my Pascal's triangle written out. So here I start out at the 0th power, 1st power, 2nd power, and up to cubed. So I know that I'll be using this line of these numbers, 1, 3, 3, 1. As you can see here, it's 1, 3, 3, 1, as in my pattern. So in my example, I have x minus 2 cubed. Now when I write out my equation, you can see I use these numbers to write my equation here. And then I solve the problem by distributing. And it gives you this equation. Now you know when it becomes a 0 power, it just cancels out. So that's why I have these marked out. And then I have my work shown down here of what I got afterwards. X cubed to start off with, right there as our first term, minus 6x squared. Now I got that from the 3 and the negative 2 right here. And then 12x was from the 3 and the negative 2 over here. And then minus 8 was from the negative 2 to the 3rd power over here. Now I wanted to check my work to see if I was right. So over here I did the FOIL method to check my work. So another way to write out this equation is to write out x minus 2 times x minus 2 times x minus 2. So otherwise we just write the same equation 3 times. And that'd be the same thing. So I did FOIL method. So we first start off with the first 2 blocks of the equation. Now when we saw that in FOIL method, which you can show here with the arrows, would be x squared minus 2x plus 4. And then we just carry down our x minus 2 that was left over. Now when we simplify this down, because negative 2x and negative 2x is negative 4x, I just wrote that down there. So now our equation is x squared minus 4x plus 4 times x minus 2. So then once we FOIL that out again and distribute it, now we have x cubed minus 2x squared minus 4x squared plus 8x plus 4x minus 8. And once that gets simplified down and you combine like terms, you get the answer that you got originally. That is adding and subtracting multiplying polynomials, presented by me, Bailey. Thank you.